So hi guys, let's look at the problem here. We're going to be continuing with our topic of logarithms, and we're going to be applying them to new scenarios. So this here is an add math style question, so if you're in CIM or doing the CIM course, it's not really necessary to attempt, but it may be good to enrich your understanding about logarithms further. So solve log y minus 6 plus log y plus 15 is equal to 2. The first thing we have to do, notice that these two are in a logarithm to the base 10, so we have to do the same thing here. The way we do that is we'd first write this as a coefficient of log 10, 10, because 2 log 10, 10, this thing here is just 1. So then this here, 2 times 1 is equal to 2. That's another way of writing it, which can be rewritten if we just bring it over here with the law of logarithms. Log 10, 10 squared, which is equal to log to the base 10, 100, which is the same as log 100, because remember that if it's not specified, if the base here isn't specified, it's automatically to the base 10. So this is rewritable as log, oops, I should just write it as LG because that's how they've written it here. And if you remember, LG is just the same as log. Okay, and we can simplify, oops, sorry, I forgot to write this. Log 100. Now, if you remember, our other logarithmic rule is that we can multiply these two when there's an addition sign. So that would give us log y minus 6, y plus 15 is equal to log 100. And now that we have a logarithm on both sides of the equation, we can just get rid of it. So we have y minus 6, y plus 15 is equal to 100. And we can see that this is going to turn out to be a quadratic. We just have to find it. So let's simplify it by expanding the brackets. Y squared plus 15y minus 6y minus 90 is equal to 100. And we can rewrite this quadratic as y squared plus 9y minus 190, which is equal to 0. Now, if we want to use inspection, we can realize that negative 190 has factors negative 10 and 19, which can rewrite it as y minus 10, y plus 19 is equal to 0. So the values of y are y equals 10 and negative 19. But we're not quite there yet, because we have to realize that if we substituted each of these values in, when we substitute negative 19 in, the first one, which would, in this case is log y minus 6, would give us log negative 19 minus 6, which is log negative 25. Problem with this is that log negative 25 can be rewritten as 10 to the power of x is equal to negative 25. And no value of x can make this equal a negative number. So that's technically not possible. Therefore, this isn't a solution, and the real answer is y equals 10. That's why whenever you get a negative answer and then you have it in logarithms, check to see if any of the logarithms, when the value is inputted, actually makes a negative number, because then it's wrong. But in this case, it's y equals 10, which is the only correct answer. Okay, so let's move on to the next problem. So log to the base 3 y plus 14 is equal to 1 plus 2 over log to the base y 3. So the first thing we have to do is notice that these two logarithms are not at the same base. One has base 3, the other has base y. And on top of that, we have to make this to the base 3 or y, whichever we choose. Well, I always think it's much, much easier if you put something to the base of a number that we already know. So I would say we would go with the base 3. So we can rewrite this as log 3 y plus 14. And then if we're making one logarithm, well, it's just log 3, 3. Because 3 to the power of x is equal to 3, then x is obviously 1. Plus 2 over, and then converting log y 3, log to the base y 3, we use change of base rule, which would give us log 3 over log 3y. And this is nice because we can just make this 1, we can cancel it out. So we can substitute our value of log y3, which is 1 over log 3y, into here. And we can simplify this further to give log 3 y plus 14 is equal to log 3. And then this here, this here can be rewritten as 2 log 3y if we just use simple division. And now we can bring this over here to make it squared and then get rid of that to make it a lot easier. Now it's very easy to actually simplify. So log 3y plus 14, equals log, and then we can actually multiply these two parts because of the addition sign here, to make it 3y squared. Now we can get rid of the logarithms as we did in the last question to give 3y squared is equal to y plus 14, which can simplify to 3y squared minus y minus 14 is equal to 0. And we can use inspection once more to simplify the quadratic into, and then let's just take a look at this. Yeah, so we can just do plus 2 minus 7. This would give this thing, which is equal to 0. So our values of y are 7 over 3 and negative 2. But we need to check again, because now we have a negative number and we have logarithms. And what did we say in the last part? We said that logarithms can't have negative numbers in it. We can substitute negative 2 into the first part, which would give log 3 12, which at the moment is not a concern. But if we substitute it into this part here, it becomes log to the base negative 2, 3. And that essentially can be rewritten as this. And this is also impossible. So our only value is 7 over 3. Y is equal to 7 over 3. And that's correct. Okay, so now let's move on to simultaneous equations with logarithms. So with this one, we can already start to simplify the different equations due to the fact that these parts over here don't have logarithms. So the way we can do this is that first let's identify that over here, log 2x plus 2y is equal to 3. What that means is that since 3 is equal to log 2, 8, x plus 2y automatically equals 8 because they already have the same base now. And x plus 2y giving 8 would actually equal 3 as a whole. So the first equation we can rewrite as x plus 2y equals 8. Now we can do the same thing with the second equation. So 1 is equal to log 2, 2. 1 equals log 2, 2. Now, with the law of logarithms, log 2, 3x minus log 2y would give log 2, 3x over y. So in this case, 3x over y is equal to 2, because we do the same thing as we did in the first equation, which means that 3x equals 2y. Now, this is very, very easy. We've just gotten 3x equals 2y, and we have 2y over here, so we can just substitute 3x into here to solve for x, which means that x plus 3x is equal to 8, 4x equals 8, and x is equal to 2. Now we can solve for y very, very easily. So, using this equation over here, 3 times 2 is equal to 2y. So, 2y is equal to 6, and y is equal to 3. So, while this problem may look very daunting at first, you can actually simplify it into a linear set of equations, which will make it very easy to solve for. So x equals 2y and y equals 3. There's only one set of solutions over here. Alright, so this is our last problem for this video, and pause it if you'd like to attempt it, but I'll go straight into it. So, first we can see that log a root b minus half is equal to log b a, and we're supposed to solve this equation for b, giving our answers in terms of a, that given that all of the variables a and b are greater than 0. First thing I'll do is, first with this part here, I don't like the idea that the square root is in there, so we're going to write it differently. So log a b to the power of half, because anything to the power of half means the square root, can be rewritten as half log a b. And now we've written it in this form. I think for the rest of the parts here, I'm going to write it in the form log AB. So log AB minus, and then half is equal to half, oops, let me rewrite this. Half log AB, and then half is equal to minus half log AA. So we want everything to the base A, which is equal to, and then we have log BA here. So let's use change of base rule to make this log AA over log AB. And this is essentially just 1. So half log AB minus half log AA is equal to 1 over log AB. And honestly, while I did write this as a logarithm, I can see now what I need to do, and I don't need to use this as a logarithm because this is also the first time I'm looking at this problem. So let's just rewrite this as half again because we actually don't need it as a logarithm. So it's half log AB minus half equals 1 over log AB. And something now I've noticed is that we can, since we've got log AB twice, let's use u substitution, which means that we just replace u with this term and then sub it in later. So let's say that log u equals log AB. Let's put in u over here. So half u minus, half u minus half is equal to 1 over u. And we can just multiply everything by u to get rid of this fraction over here. So half u squared minus half u is equal to 1. And the fact that we have fractions in this, what seems to be a quadratic, is annoying. So we should just multiply everything by 2 to get rid of it. So u squared minus u is equal to 2. Rewrite this as u squared minus u plus, no, not plus 2, minus 2 equals 0. And then this is just a quadratic we can solve with inspection very easily. U minus 2, u plus 1 equals 0. So u equals 2 or negative 1. Now we have to substitute log AB with u again. So let's say log AB is one of these solutions, which is 2. Well, then in that way, we can rewrite this again because now it's the time where we have to try and rewrite logarithms. So we can rewrite this as a to the power of a squared is equal to b. Yeah, a squared is equal to b. So if you were to substitute a squared into b, that would give us log a squared, which would give us 2 log AA, which is 2. So this is one way of writing it. B is a squared. Now let's say that we have log AB equals negative 1. So if we have a to the power of negative 1 equals b, equals b. Give me a second while I try and get this to work. Let's just move it down a bit, I think. So let's say we have log AB is equal to negative 1. That's the same way as writing a to the power of negative 1 is equal to b. So b is equal to 1 over a. So there's 2 ways of writing it. B equals a squared and b equals 1 over a. Okay, so we went through 4 different problems there. Let's just recap what we need now. Now, when evaluating complicated logarithmic problems like that, the first thing we should do is write them to the same base. If they're not in a logarithm, I recommend you put them in a logarithm because then it makes them like you can collect them in one go, so and have a logarithm on each side. And after you've got that, after you have log x equals log y, where x and y are whatever terms you've collected, get rid of logs. This is important because logarithms with variables can make them very complicated. Just try and set it up in a way you can make it a linear or quadratic term that is easier to factor and get the solutions of. If that's not the case, and you've got 2 unknowns, you may want to use, or you've got 2 like different terms that have the same like base and like number. Then use u substitution. Like in the last one, two of the terms had log to the base a, b. You can substitute u into it to get one variable, and then you can replace, and then you can like solve the quadratic or whatever equation you have in terms of u, and solve. And then finally, replace expression with u again, and solve. So for example, if you substituted log x as u and log x equals 2, then you can be pretty sure that x is equal to 100 in this case. So solve in that way. Anyway, I think apart from that, that's all you need to know. With simultaneous equations, also remember you can make them in linear form, and it's so much easier to understand. It's just the logarithms. You have to use a bit of laws of logarithms in order to like apply them. So thanks so much for watching. I think that's enough with logarithms. If you've got some problems with logarithms you'd like me to solve, do let me know and I'll post a video on them, on how to solve them. But other than that, I think that's it for this video.